All right, hope you guys are excited. Buckle in. This one gets a little bit more complicated, but we're gonna talk through it. We'll make sense of it. But yeah, let's take a look. We have a picture inside a frame that has an area of 375 centimeters squared. So the difference with this problem is when you guys have had your pictures, they give you the dimensions of your picture. You know, maybe it's 9 by 11 or something like that. We don't know what the dimensions of the picture are, but we do know that the area is 375. We can see that there's a frame that is X units going all the way around, and we know that the total length is 20 centimeters and the total width is 30 centimeters. So how do we approach this problem? Well, we're going to focus on the information we were given. We were given that the picture has an area of 375 centimeters squared. So we're going to write an equation for the area of the picture. We can see that the picture is a rectangle. So area equals length times width. And then I'm just going to make a note that this is not an equation for the total area. This is just an equation for the area of the picture because that's what they gave us. That's kind of the key information here. All right, so let's fill in what we can. The area of the picture is 375, so we're going to plug that in for our area. Now the tricky part is what is the length and the width of the picture? We don't know. Here's what we do know. We know that this whole length is 20 centimeters. So if we take that 20 centimeters and we remove, I'm going to use a little eraser, we remove this X from that side and we remove this X from this side. Do you see how that's leaving us with the length of our picture? So how do we remove? In mathematics, we subtract. So our length of our picture is going to be 20, the total length with the frame, minus the frame. And we have, you just saw me do it. I just erased an X over here and I erased an X over there. So we removed 2 of those X's, so minus 2X. So that is the length, 20 minus 2X. All right, same idea. The width, we know that the whole thing is 30, and we want to remove an X from the top and remove an X from the bottom so that we are left with just the width of the picture. So the width of the picture is the total 30, and we take out those 2 X's in the frame. So 30 minus 2X. And that's how we get our equation to work with. So we're going to put this into standard form. So set our equation equal to 0. We're going to multiply everything out. And then we got some fun factoring ahead. It's a good review, but just make sure you're paying attention. All right, so we are going to distribute the 20. 20 times 30 is 600. 20 times a negative 2x is minus 40x. Now let's distribute the negative 2x. Negative 2x times 30 is negative 60x. Negative 2x times negative 2x. That is a negative times negative, so it's going to be a positive 4x squared. All right, so I'm going to do a couple things all together. We do want to set our equation equal to 0, so we're going to subtract 375. I'm going to subtract it from its like term over here. That gives us 0 equals. Now when I rewrite all of this, we're going to combine like terms, but I also want it in the proper order, which means I want the x squared term first. So I'm going to write the 4x squared. And then we've got some x's we can combine. Negative 40x minus 60x is minus 100x. And now we can do that math. What is 600 minus 375? A positive 225. Okay, so we've got standard form. We have our equation set equal to 0. Now let's factor it. Well, once again, we have to take note of our x squared term. It has a 4 in front. Can we divide both sides of the equation by 4? Well, we can, but we only want to do it if things divide evenly. We don't want to do factoring with decimals. You guys have never even seen that before, so we're certainly not going to start doing that now. This term will divide by 4. 100 will divide by 4. 225 will not divide by 4. So we're stuck with this 4 in front of the x squared. We cannot find factors of 225 that add up to negative 100. It's not going to work out. So we are going to factor with the box method. So anytime your a value is not equal to 1, this is how we do our factoring. So when we factor with the box method, remember your first term, that 4x squared, is going to go in the top left. The last term, 225, goes in the bottom right. And then to fill in our other two boxes, we have to take our a value times our c value. So 4 times 225 is 900. And those are the factors we want that will add up to our b value of negative 100. All right, so we can go through our factors of 900. Sometimes we might think of them a little bit faster. So with 900, I think about 10 times 90. 10 times 90 is 900, and 10 plus 90 is 100. Again, we're trying to find a factor pair that adds up to this. Now that is a negative 100. Because it's a negative 100, I'm going to want both of these factors to be negative. So quick check, do they still multiply to a positive 900? They do. Do they add up to a negative 100? They do. All right, so we're going to put a negative 10x in one box and a negative 90x in the other, and then we're just doing GCF factoring. So we're going to look for a GCF for each row in each column, and then those will be our binomial factors. So 4x squared minus 10x, they have a 2x in common, negative 90x and 225. So this right here, this negative 90x would be considered our leading term. So that tells me that I want a negative GCF. So it's going to be something that's negative. And the GCF for 90 and 225 is 45. So that's going to be a negative 45. All right, now we're going to find the GCF of each column. So 4x squared and negative 90x, the leading term is positive, so that's going to be a positive. That's also going to be a 2x. I know some of these aren't as obvious with these big numbers. Our next column, we need the GCF here. Leading term is negative, so I know it's going to be negative. And then a GCF for 10x and 225 is 5. So now we can do our quick little check. Is 2x times 2x 4x squared? It is. Is 2x times negative 5 negative 10x? It is. This is where we'll catch if we have the right signs. So we always want to take this, it's a 10-second check. Of course, it's taking me longer than 10 seconds to explain it, but you guys can check this real quick before you finish your factoring. 2x times negative 45, negative 90x, that looks good. Negative 45 times negative 5 is a positive 225. So we are good. So 2x minus 5 is in one parenthesis, and then this 2x and this minus 45 go in the other parenthesis. I'm going to carry down our equal 0. Now we have factored form. We have factored form set equal to 0, so we can set each factor equal to 0. 2x minus 5 equals 0. 2x minus 45 equals 0. I can predict fractions because of the 2 in front of the x. We don't always get a fraction. Maybe it will divide evenly, but we know we're going to have to divide by the 2. So we add 5 to both sides. 2x equals 5. Divide both sides by 2, and we get x equals 5 halves. We're dealing with a word problem, so decimals are also okay, as long as we don't have to do some weird rounding. 5 divided by 2 is 2.5. Then we're going to solve this one, add 45 to both sides. 2x equals 45, divide by 2. 45 divided by 2 is 22.5. All right, so because it was a quadratic equation, we got two solutions. And let's just see if both solutions make sense in the context of our problem. Now, normally I would say, because x represents the width of your frame, I think it is, right? We need to make sure we don't have any negative values. They're both positive, so it's real easy to say, oh yeah, they're good, they're positive. But if we look at our picture, we got a 2.5 and a 22.5. Here's where we're going to have an issue. If this length is 20 total centimeters, then is it possible for the length of the frame, just this part right here, to be 22.5, to be bigger than what the whole length is? That's not possible because we have our picture frame, we have our x value here and another x value there. So that 22.5 is just too big. It doesn't make sense when we go back and look at it. So x equals 2.5, which is the width of the frame. So the width of the frame is 2.5, and then our unit is centimeters.